All right, let's look at a concept that is old but new compared relative to what we're talking about today, and that's this idea of speed, right? Um, we're going to look at speed, both speed of an object and the rotational or angular speed of a circle. So when you talk about distance, rate, and time, this is the old triangle that was taught to me when I was in school. Okay, the formula you probably remember is distance equals rate times time, right? But we always used this triangle, and we'd say whatever you want to solve for, cover it up, right? And then you would have the equation or the calculation you need to do. Like, for example, if you wanted to know distance, you cover up the d and you get RT, rate times time. Okay. If you wanted to solve for the rate, right? If you wanted to know the speed of an object and you knew the distance it covered and the time that it took, you would have that formula, right? If you divided both sides of this by t. So if I was solving for the rate, I would get distance divided by time. So it's just a quick way to get the calculation that you needed to do. This was kind of taught to me before algebra was involved, right? Where we could manipulate formulas that had multiple variables like this. We're going to look at, if you will, objects around a circle. So if there's an object that's traveling a circular path, okay, over a certain period of time, let's say this object moves along this circular path up to here, okay, the distance that it covers is this distance right here. Well, that distance is an arc length, right? So we would call that S. Now it is, even though it's curved on could still be written as a linear distance. Like if you took this, and I wish I could animate this, but I can't. I'm limited by the tools that I have here. But if you took this curve and you unfurled it into a straight line, it still could be considered, a straight line distance, probably similar to a length that looks like that, right? It's not perfect, but you get the idea. So it is still a line that can be measured in terms of inches, feet, meters. The fact that it's curved doesn't mean it's not linear, if that makes sense, right? We think about lines in geometry, we think about straight lines, okay? But this is still could be considered a linear distance if the word I like to use is unfurled that, okay? And the only reason that we're showing this is because we're going to have a quote unquote new formula for linear speed along an arc. We're going to use V for that. So V represents the linear speed along a circular arc. All right, well, let's just say along an arc length. Okay. So the speed is equal to, and here's the formula. It's still this formula, right? Rate equals distance over time, but instead of D for distance, we're going to use S for arc length. Okay. So this is if you want to call it a new formula, I mean, you can, but it's really just an old formula using new variables, okay, specific to shapes that look like this. All right, so this is a formula that we can use. And now arc length, you remember that arc length, one of the formulas that we just talked about for this, okay, and I don't want to get too convoluted, but we had the formula for calculating the radian measurement of an angle, okay, and to find the radian measurement of an angle, you take the arc length and divide by r. And that gave rise to a formula where you can find the arc length of a circle if you know the measure of the central angle in radians and you multiply it times the radius. So in other words, this linear speed, right, which is equal to the arc length divided by t, could be rewritten as r theta over t. And that's if you know the radius of the circle and if you know the angle that the circle or the object rotates through to go from one space to another. So even though the actual distance might not be given, if you know, a certain object is 10 feet away from the center and it rotates 60 degrees, that's this calculation right here, okay? So this is a different way of representing linear speed along an arc length, and we're just using that substitution here, all right?